Hello, everybody. My name is Hamid with a very weird last name, Noghanibehambari. That's the way we spell it, Noghanibehambari. But my name is Hamid, and everybody calls me Hamid. Uh, I have a bachelor degree in electrical engineering and a master in economics and finance. And now I'm a PhD candidate in Texas Tech University. And my main field of interest is labor economics and health economics. And I'm happy and excited to present this paper today to you, entitled Drilling, Pollution, and Infant Health. In summary, in this paper, we are trying to link the drilling to pollution and birth outcomes. This study has been done by Kai Gittings and Travis Roach. And I should mention this, that it's a work in progress, actually. And so we didn't have any written manuscript to share with you. So we greatly appreciate your comments or suggestions or questions, anything. So the outline of my presentation. First, I will talk about the way that drilling can affect pollution, and then talk about fetal origin hypothesis to talk about why pollution matters for birth outcomes, and then the direct link between drilling and birth outcomes, and backing that up with a little bit of literature review. Then I will talk about empirical strategy, data sources, the main results, and the subsamples, the main results in the subsamples, and heterogeneity of the results by drilling type. Then I will talk about the economic significance of our findings. And finally, I will conclude this presentation. So during past 2 decades, the main engine of US oil and gas extraction has been hydraulic fracturing, also known as fracking or hydrofracturing, or unconventional type of drilling. Fracking starts with drilling a well vertically into the ground up to a depth of sometimes 2 to 3 miles, and then turn 90 degrees and then continue drilling horizontally for, in some cases, several miles. And then they will stimulate the well with a high pressurized liquid in order to generate cracks in deep rock formations. And then they extract oil and gas. So the main shock in oil and gas production in US for at least the past 20 years comes from over time changes in drilling technology combined with cross-region variation in oil and gas reservoir. The fracking, the main shock to fracking started around the years 2000 to 2007. So we have pre-fracking period in our data and post-fracking period. From 2000 to 2017, oil production increased from 2.1 to 3.4 billion barrels, which is an increase of about 60%. And gas production rose from 24.1 to 33.3 trillion cubic feet, which is an increase about 40%. So we have a large shock to drilling and oil and gas extraction between 2000 to 2017. Now, drilling and oil gas extraction affects local societies in many ways, including its effects on environment and air quality. Drilling, interestingly and surprisingly, could improve air quality. How? It increases the supply of natural gas in the market, so it will lower the price of natural gas, and it will generate some incentive for electricity power plant productions to substitute natural gas for coal as a primary fuel in the power plant. Now, natural gas has an advantage over coal. That is, natural gas burns more cleanly and it leaves lower CO2, carbon dioxide. So it can improve air quality. However, in many other ways, drilling has adverse effects on air quality. For example, diesel combustion of heavy trucks and drilling machinery, road dust, fugitive emissions, flaring or flare stack, which is burning unwanted gas at the gas station, at the well stations, and also combustion at compressor stations. compressor stations for natural gas. Several studies investigate the net effect of drilling and oil gas extraction on pollution, and they find that drilling increases pollution, and more importantly, it increases health detrimental pollutants such as ozone, volatile organic compounds, nitrogen dioxide and nitrogen monoxide, hydrogen sulfide, benzene, toluene, particulate matters less than 2.5 micrometers or PM 2.5, etc. So here we have a shock to pollution from oil and gas extraction. But why pollution matters for birth outcomes? Fetal origin hypothesis tries to explain this link. Note that the genetic variation among humans is very minuscule, about 0.1%. So it's not the DNA or genes that makes us individually different, it's epigenome. What is epigenome? Epigenome is a multitude of chemical compounds that are attached to DNA and can switch off some genes or switch them on. Mm? So, in a way, epigenome is acting like a software while genes and DNA acts like hardware. The software, epigenome, can execute some commands and order the DNA to switch off or switch on or turn off some genes. How, for example, epigenome can attach a methyl molecule to the DNA in a process called methylating the DNA and silences some genes off. Mm. The main thing that can start these switches that can program epigenome is environmental factors. For example, assume that due to a famine, mothers are having difficulty taking nutrition. So in this situation, the fetus is at danger. The reproductive system responds to this external stressor, environmental factor, with the main purpose of survival of the fetus. So it will program epigenome to silences off some genes that are related to growth so that the fetus demands lower nutrition and may be able to survive the famine. However, the result is that we have a newborn baby that is low in birth weight and weak. So in this way, mm, excuse me, is there any question? Okay. So in this way, fetal origin hypothesis is explaining why in utero period is a very critical period for birth outcomes and also for later life trajectory of outcomes. Now, several studies investigate the link between pollution and health and specifically birth outcomes. For example, Curry, Neidel, and Schmieder 2009 investigated the effect of pollution on birth outcomes in New Jersey during 1990s. And they find that carbon monoxide, ozone, and PM10 are associated with negative birth outcomes. For example, a 1 unit rise in the mean of carbon monoxide of a mean of 1.64 ppm part per million, an increase of about 60%, lowers birth weight by 17 grams. In a similar study, Curry and Neidel 2005 investigated the effect of pollution in another measure of infants' health, which is infant mortality. They investigated this effect in California during 1990s and showed that carbon monoxide considerably increases infant mortality. For example, a 1 unit fall in the mean of CO of a mean of 1.99 ppm, a reduction of about 50%, prevents 34 deaths per 100,000 live births. Therefore, we have a literature that shows pollution is affecting birth outcomes. Now, we've seen that drilling increases pollution and pollution has negative birth outcomes. So an interesting avenue in the research is to link drilling with birth outcomes directly. Two studies up to now have investigated this link. And oddly enough, both of them are using the same region in the very similar time period and a very similar identification strategy. In the recent one, HEAL 2018 shows that the development in shale gas the development of shale gas in Pennsylvania during 2003 to 2010 was associated with negative birth outcomes. She's comparing the mothers residing within 2.5 kilometers of a gas well to mothers outside of this range after the development to before, and finds that mothers residing within a 2.5 kilometer of a gas well have 7 percentage points higher likelihood of having a low birth weight child. In a similar study, Curry, Greenstone, and Meckel 2017 investigated the effect of hydraulic fracturing in Pennsylvania between 2004 and 2013 on birth outcomes. They compare mothers residing within 0 to 1, 1 to 2, and 2 to 3 kilometers of a gas well to mothers residing between 3 to 15 kilometers of a well after the development of a hydraulic fracturing well to before, and finds that mothers residing within a 1 kilometer of a well have 1.6 percentage points higher likelihood of giving birth to a low birth weight child. 1.6. However, in their study, when they include mother fixed effects, marginal effects diminish and become, in most cases, statistically insignificant. Now, when we look at these two papers, in the first one, being in a 2.5 kilometer, have 7 percentage points marginal effect. Here, within a 1 kilometer, where we expect that effect to be much larger, it's actually much smaller. So this literature is not conclusive in the magnitude economic, uh, in the marginal effect, and also not statistically conclusive, right? In the second study, the coefficients become statistically insignificant. Therefore, this literature needs to be reevaluated. The contribution and novelty of our study to this literature is first, we look into both production of oil and gas together. Second, we disaggregate the production by type for vertical, directional, horizontal separately. We use data for all US counties rather than just a specific region over a relatively longer period of time, 18 years. We also look into a very rich set of health outcomes rather than just birth weight and low birth weight. And also, nature of the data allows us to quantify the effect of drilling based on the amount of production, oil equivalent barrels, and also the number of wells. The primary data source that we use is birth certificate data from natality detail files. The second one, drilling data from restricted use drilling info. Drilling info is a private company that gathers information on US oil and gas across all counties. The third one is pollution data from EPA, Environmental Protection Agency, and the rest of data sources are from standard sources. For example, industry-specific employment from QCW, and unemployment from local area unemployment statistics of BLS, population composition data from SEER, income and wage data from BEA, job destruction data from QWI, and union and Medicaid coverage data are calculated on a state by year frequency from CPS. And finally, in the implication part, we also use publicly available matched multiple birth data from NCHS. And our data covers the years 2000 to 2017. So before going to the empirical part, let's take a look at the summary stat and see how the data looks like. This table shows the summary statistic of infants' characteristics. And I want you to see some of these numbers. For example, the average birth weight is 3,275 grams. On average, 8% of births are categorized as low birth weight, having a birth weight less than 2,500 grams. On average, 1% of births are categorized as very low birth weight, having a low birth weight less than 1,500 grams. And average weekly intrauterine growth, weekly gain in weight or fetal growth is 84 grams per week. Another important summary statistic table is that of production, that is county by month by year frequency. We use three measures for production or drilling activity generally. The first one is total oil production in barrels plus total gas production in oil equivalent barrels. On average, the production is 127,000 oil equivalent barrels in a county by month by year frequency, but standard deviation is 1.1 million. The second measure is well count, the number of active wells in the county. The average is 147. And the third measure is new well counts, the number of newly drilled wells in the county in each month, in each year. On average, one newly drilled wells with a standard deviation of 7. And as you may have noticed, we have lots of zeros. Medians are 0, standard deviations are large, and that is because most of the counties in US don't have any oil and gas production activity. And actually about 1/3 of them have any production over our time period, about 1,100 counties versus more than 3,100 counties in US. That is why we see lots of zeros in the data, and the medians are 0, standard deviations are large. This figure shows the evolution of oil and gas production in terms of log of production relative to 2000, log of growth, long growth, for different drilling type, for example, horizontal gas, horizontal oil, etc., and over the years, 2000 to 2017. Look here, horizontal gas. From 2000 to 2017, horizontal gas production increased by 20,000%, increased by about 200 folds, which is e to the power of 5.2 here, right? This is log of production relative to 2000, log of growth. The second one is that of horizontal oil production, which increased by about 60 folds during this time period. Large shocks. The third one, directional gas, which increased by about 200%. Then directional oil, which increased by about 80%. And then vertical oil and vertical gas, their growth was very small, almost 0. And a small fraction of wells in the drilling info data are labeled as unknown type of drilling or uncertain type of drilling. And because the drilling type was unknown, and their growth is even negative during this time period. And note that these types, horizontal oil and horizontal gas, directional oil and directional gas, are referred to as unconventional type of drilling. And vertical oil and vertical gas usually referred to as conventional type. This figure shows the density distribution of low birth weight in 2 time periods: pre-fracking period between 2000 to 2007 and post-fracking period 2008 to 2017 in the bottom panels. For 2 sets of counties with 0 production, the left panels, without any oil gas activity, and counties at the upper quartile of production growth, the right panels. For both time period, compared to counties with 0 production, counties at the upper quartile of production growth had higher incidences of low birth weight. Compare the number 0.0778 to 0.0775. And the same thing here, 0.0784, 0.0803. And when we look at the upper counties at the upper quartile of production growth, the right panels, Compared to pre-fracking period, the post-fracking period shows higher incidences of low birth weight, the average of 0.0803 versus 0.0778. So in a very correlational manner, this figure is suggesting the negative health effect of drilling. This figure shows the geographic distribution of oil and gas production across all US counties. And you see states such as Texas, Colorado, Nebraska, South Dakota, North Dakota, Minnesota, partly Pennsylvania, and Ohio are mainly oil producing counties in US. And I want you to remember this region where most of the production happens. Here, I will call it production belt. I will come back here later. This part, production belt. Now, when we are thinking about the empirical method and the effect of pollution on birth outcome, for example, we have a pollution data problem. Only about 40% of counties in US had any pollution monitors. It means that only 40% reported at least once for one pollutant over 18 years. And more than that, in order to report a specific criteria pollutant, the monitor needs to be equipped with a necessary device, and not every monitor is equipped with that device. And the problem is worsened because not all well-equipped monitors report pollution on a regular basis. Why is it important? Because these missing intervals could be correlated with pollution, and pollution is correlated with birth outcomes, so we have a problem here. In an interesting study, Granger and Schreiber, 2019, showed that these non-measuring, non-reporting intervals, these missing intervals in the pollution data, is discriminative. How? Those local regulators avoid reporting data when the pollution is high at hotspot for poorer counties versus richer counties. So these missing intervals is first correlated with pollution and second correlated with demographic characteristics. And both of them are correlated with birth outcomes. So we have a problem with pollution data. We need to take that into account. But even if the pollution data was perfect, one might think that a 2SLS is a good approach, but it's not. Why? Because even if the pollution data was perfect, a 2SLS approach, the effect of production on pollution and then pollution on birth outcomes, violate the exclusion restriction criteria. How? So take an endogenous variable like ozone. So production, oil and gas production increases ozone. Fine. So the relevance assumption holds. But this production also is associated with an increase in CO, NO2, nitrogen monoxide, PM2.5, and all these are hidden in the error term, right? So we have an exclusion restriction problem here. We cannot use 2SLS. And for this reason, we prefer a reduced form analysis directly from production to birth outcomes. Now, before going to the empirical method, um, let's take a look at one of these uh, monitors, monitors that report carbon monoxide, monitors that consistently report carbon monoxide. This map shows the geographic distribution of those pollution monitors that consistently report, which means that they report at least once a year, but consistently over the years between 2000 to 2017. And you see how few there are and how sporadic they are. And look here at the production belt that I showed you. You see how few these pollution monitors are. Actually, all of these pollution monitors add up to 107 versus 3,100 counties in US. So we have a pollution data, right? But let's reevaluate the drilling pollution connection, the drilling pollution link. that was reported in the literature. Here, we want to do that to find the first order effects of drilling on pollution. This table is from the results of county by year panel data regressions that also include county fixed effect and year fixed effect and a county by year linear trend. The outcomes are reported in rows and the independent variables are reported in columns within each panel. So first independent variable, total production, oil and gas in terms of oil equivalent. The second panel, the independent variables are oil and gas separately. And the panel C, the third panel, total number of active well counts in the county. The first outcome, nitrogen dioxide, second outcome, nitrogen monoxide, and each block here, for example, and here, represents a separate regression. The first number is marginal effect, the second number is standard error, and the third number is elasticity, and then R squared and observation. For example, 1,000,000 barrels of oil equivalent production increases nitrogen dioxide by 0.14 units. And the unit here is ppb, part per billion, over 1,000 square foot of county area. Or equivalently, we can just look at the elasticity. Doubling the amount of production increases nitrogen dioxide by 0.6 percentage. Or picking another number, total production on carbon monoxide and looking at elasticity. Doubling the amount of production increases carbon monoxide by 0.8 percentage. Or another number, well counts and carbon monoxide here. Doubling the number of active wells in a county increases carbon monoxide by 1.9 percentage. Now, when we look at all these coefficients in this table, we see that first, all of them are positive, implying that drilling is increasing pollution. Most of these coefficients are statistically significant. And more than that, the effect of drilling on pollution is not solely attributable to oil or gas. Sometimes it's both, like the case of nitrogen dioxide, sometimes only oil, nitrogen monoxide, or sometimes only gas, carbon monoxide. Okay? Now, we see the same pattern when we look at other pollutants like PM2.5, PM10, MP-xylene, benzene. And for example, look at this number. Doubling the amount of production, looking at elasticity, increases PM2.5 by 0.5 percentage. Or doubling the number of wells that are active in a county increases PM2.5 by 1.3 percentage. And again, all of these numbers are positive and most of them statistically significant. And also we see the same pattern when we look at some outcomes that are sparsely reported and less studied, but health detrimental, like toluene, ethylbenzene, xylene, all coefficients positive and in most cases statistically significant. And in this case, at 1% level. So we have a strong first order effect, which means drilling is increasing pollution, backed up by literature and reevaluated here. But we go to the direct effect of drilling on birth outcomes. The main idea in our empirical strategy is to compare the birth outcomes of mothers that are exposed to production, that are residing in counties with oil and gas production, compared to outcomes of mothers that are residing in counties with zero production over the years. And the main assumption here is that the birth outcomes of the treated mothers, those exposed mothers residing in oil and gas producing counties, follows the same path and is determined by the same influences as those unexposed mothers who are residing in counties with zero production, except for the fact that they experienced a sharp rise in oil and gas production. And this assumption lends itself to the fact that, quite likely, the over time changes in drilling technology and fracking technology, combined with predetermined geological locations of these oil and gas reservoir, are quite likely, probably, orthogonal to treated mother's characteristics, to those exposed mother characteristics. Now, we believe that this assumption holds, but we look into two sources of endogeneity later, and I will talk about them later in my presentation. Now, we use the following specification in OLS models. The outcome Y is birth outcomes to mother I in county C at time in terms of year by month T. The main measure of drilling activity is drill, specific to in utero period. So the average monthly of a mother who had 10 months of gestation will be different than a mother in the same county who had a gestational period of 4 months. There is specific drilling exposure to each mother, production exposure to each mother. And we use three measures: oil equivalent production, total number of wells, and number of newly drilled wells. And then we have a series of county fixed effect to control for those time invariant fixed county characteristics, and also a series of year by month fixed effects that not only include for those geographically fixed time characteristics, but also for some seasonality in birth outcomes as well. And then we include a series of county by year time trend, linear time trend. In X, we include some state and county covariates, and in Z, some parental characteristics. And those state by year and county by year characteristics include income per capita, average wages, total annual wages, job destruction rate, unemployment rate, percentage of different composition in the population, percentage of different employment in different industries, state level minimum wage, state level union coverage rate and Medicaid coverage rate, and also log of population. In Z, we include some mother's characteristics, all in dummies, including race, age, ethnicity, marital status, education, prenatal doctor visit, and smoking behavior during pregnancy. And also limited characteristics for father, including age and demographics, race and ethnicity. And since there are some missing values in Z, in matrix Z, parental characteristics, specifically for father's characteristic, because either mothers don't report or they don't know, but for any reason, to control for that, we include a series of missing indicators for any of those parental missing characteristics in matrix Z. And finally, we cluster standard errors at the county level. So finally, main results. This table shows the main results of our paper. And all the regressions include full fixed effect and county by year trend and all those covariates. Excuse me. In this table, independent variables are reported in columns: production, well counts, and new well counts. And outcomes are reported in rows, and outcomes are reported in columns: birth weight, low birth weight, etc. In this way, each block, each cell represents a separate regression with the same structure: marginal effect, standard error, then elasticity in bracket, then R squared, and observation at the end of the table and at the end of the column. We look into 8 outcomes. First, birth weight in grams, low birth weight, a dummy that is one if birth weight is less than 2,500 grams, very low birth weight when birth weight is less than 1,500 grams, small for gestational age, which is a dummy that equals 1 if birth weight is at the bottom 10th percentile of birth weight distribution relative specific to gestational age, gestational week. And fifth outcome, full term birth weight or birth weight at maturity when infants reach 37 to 42 weeks of gestation. And the next one, fetal growth, the weekly gain in weight in terms of grams per week, simply birth weight divided by gestational weeks. The seventh measure is Opcar Score, which is a health measure, consists of 5 tests for appearance, pulse, grimace, activity, and respiration. Each test takes 1 minute, and scores between 0 and 2. So Opcar Score is a 5-minute test that scores between 0 to 10. And finally, low Opcar Score is a dummy that equals 1 if Opcar Score is less than 8. Now, let's look at the results. For example, this number here, minus 3.2. It tells us that 1,000,000 barrels of oil equivalent production in the county of residence during prenatal development period is associated with 3.2 lower grams in birth weight. Or looking at the elasticity, doubling the amount of production reduces birth weight by 0.02 percentage. Or we can look at the outcome of low birth weight. Doubling the amount of production increases the incidence of low birth weight by 0.3 percentage. I'm looking at the elasticity, okay? And also we can look at very low birth weight and well counts, for example. Doubling the number of wells in the county is associated with 3.7 percentage increase in the incidence of very low birth weight. And as you see, all these coefficients are statistically significant for birth weight and low birth weight, not for production and very low birth weight, but all of them positive, all of them implying the negative externality of drilling on birth outcomes. Then we have the same story for small for gestational age. Production increases small for gestational age, and also well counts, not statistically for new well counts. We see the same negative effect on full-term birth weight, the same negative effect on fetal growth. For example, here, doubling the number of new wells drilled in the county reduces fetal growth by 0.01 percentage. And we have the same negative effect for Opcar score, but the coefficients are imprecisely estimated. And when we look at low Opcar score, we see the same negative health effect or positive effect on low Opcar score, and it is significant for production. For example, doubling the amount of production increases low Opcar score by 0.5 percentage. So when we look at all these coefficients, we see that the signs are consistent. All of them are implying negative health effects. And more than that, most of these coefficients are statistically significant. Okay? It would be interesting to compare our results with that of drilling and birth outcome literature. However, that literature uh, as we've seen, use a dummy for the vicinity of a mother to a well, and it would be hard. But it's possible and interesting to compare our results with the pollution birth outcome literature. For example, Curry, Neidel, and Schmieder 2009 showed that a 60% rise in carbon monoxide reduces birth weight by 17 grams. Now, in the table of the first order effect, we have the elasticity between oil and gas production and carbon monoxide. And also from the main result table, we have the elasticity between production and birth weight. We can calculate the shock needed to give to the production in order to increase carbon monoxide by 60%, and then use that shock, give it to birth weight, see what happens from these two elasticities. So a back of an envelope calculation tells us that a 60% oil and gas production shock, drilling driven rise in CO decreases birth weight by 46 grams. Now we have 46 and they had 17. Why is it different? Because when production goes up, carbon monoxide goes up, fine, but it also increases ozone, nitrogen dioxide, nitrogen monoxide, and all of them are health detrimental. So it makes sense that we are getting a larger effects. Okay? But the point here is that Our results, it's not off the radar. 1746, it's not off the radar. And also it makes sense that it's larger. So we believe that our results are in line with the literature, at least to some extent. In the next step, we investigate the effect of drilling on birth outcomes for the subsample of counties that had any production over the sample period, counties with positive production. That are about 1/3 of counties, and that is why we see much lower number of observation, 17 million in the main result. Here we have 25 million, 1/3 almost. And the structure of table is like before. In this table, the idea is that we're comparing the outcomes of mothers in counties with higher production growth to counties with lower production growth. For example, look at this number, minus 2.7. It's comparable to minus 3.2 in the table of main results. An increase of 1 million barrels of oil equivalent production reduces birth weight by 2.7 grams. But when we look at the elasticity, which is a better measure because the average production in this table and the previous table is different. The dosage of the treatment in the previous table was larger because we're comparing 0 to positive. But here the dosage of treatment is definitely smaller because we're at the intensive margin comparing higher production to lower production counties. So it makes sense that we are getting larger elasticities. For example, doubling the amount of production reduces birth weight by almost 0.05 percentage versus 0.02 percentage in the table of main results. And doubling the production increases low birth weight by almost 1 percentage, much larger than the table of main results. Doubling the number of well counts increases very low birth weight by 12 percentage. So the elasticities are larger, but the marginal effects are comparable. 23 basis point previous table, 26 basis point here. 13 basis point previous table, 15 basis point here. And also, all coefficients in terms of their sign are in line with the hypothesis that drilling has negative association with birth outcomes. We see the same story for small for gestational age, although statistically insignificant. The same negative effect on full-term birth weight, negative effect on fetal growth, and negative but imprecisely estimated effect on Opcar score, and also the same story for low Opcar score. In the next step, we disaggregate the production by type of production for directional, horizontal, and vertical. For example, look at the outcome of birth weight. Minus 19, the effect of drilling production, compare it to minus 3.2 in the table of main results. So vertical drilling has the largest effect. Then the directional drilling, minus 14 versus minus 3.2. And also the elasticities are much larger for vertical and directional. It tells us that there are heterogeneity. Some types of drilling are more pollutant, have higher negative birth outcomes. And we see the same stories either for marginal effects or elasticities when we look at low birth weight and also other outcomes as well. And in most cases, the signs are consistent, implying a negative health effect. And in most cases, they are statistically significant. And the only anomaly here is that of uncertain drilling on Opcar score, which is positive, although very small in magnitude compared to the others, and statistically insignificant. This is the only anomaly in sign, of course. Now, up to now, we've talked about the effect of drilling on pollution, and we show that it is associated with negative birth outcomes. But some studies showed that fracking boom increases fertility. So the fertility response is no problem for us. It doesn't create a problem. It will create a problem if, and it will bias the estimates if there are certain demographic and economic characteristics of mothers that leads them to respond to the boom by selecting themselves into maternity ward or by deciding not to select themselves into maternity ward. And those characteristics are definitely correlated with birth outcomes. Therefore, we have a sample selection issue, or we have a selective fertility problem, an endogenous fertility issue. Here in this table, we investigate for that selective fertility or the endogenous fertility issue. The table shows the results of county by year panel data regressions that also include for county fixed effect, year fixed effects, and a county by year trend. So each cell represents a separate regressions with the outcomes in rows and independent variables in columns. For example, an additional million barrels of oil equivalent raises birth counts by 0.73 units. Now, when we look at the share of mothers' characteristics, there was no response in the share of teenage mothers on production, well counts, and new well counts. However, there are small evidences that share of white mothers increased as a response to an increase in production, not for well counts, and yes, for new well counts too. The share of Black mothers reduces as a response to production and newly drilled wells in the county. Now, these two positive effect of new well counts for the share of white mothers and negative for the share of Black mothers creates a problem for us, and it under biased our estimates. Why? Because white mothers usually have infants with higher health endowments for some observable reasons and unobservable reasons that cannot be controlled for by including a series of race dummies in the regressions. And the same story goes for the Black mothers, because Black mothers usually have infants with lower health endowment, and they are decreasing, they are responding with reducing their fertility. So our coefficients are underbiased, probably, at least with this limited evidence here. When we look at the share of Native Americans, it didn't respond. The share of Hispanics, it responded slightly to production. For married mothers, there's small and little evidence that they responded to newly drilled wells. The share of mothers with less than high school education didn't change. The share of mothers with high school education didn't change. The share of mothers with some college didn't change, but the share of mothers with bachelor and above education did change. It did decrease as a response to production and as a response to newly drilled wells. What does it mean for us? It means that our coefficients are probably overstating the true effects. Why? Because if we believe that these coefficients are true and that based on a limited literature, that the maternal education, these high educated mothers usually have higher health endowment, higher infants with higher health endowment, then our coefficients are overbiased, are overstating the true effects. But generally, when we look at all these coefficients, we see that most of them are statistically insignificant. One, the signs are not consistent over different measures of drilling activity. For example, look at Black mothers, share of Blacks. Here I have a negative sign, here positive sign, here negative and significant at 5%. So they are not consistent across different measures. And third is that they are not systematic because, for example, here it suggests that probably our coefficients are under biased. Here it suggests that our coefficients are probably over biased. So they are not consistent and systematic. Therefore, we don't believe that this selective fertility is overruling the relationship between drilling, production, and pollution and birth outcomes. Okay. So another concern is that birth outcomes are seasonal, and probably production is seasonal, and there are some association between seasonality in production and seasonality in birth outcomes that may overstate, underbias, or overbias the estimates. This figure shows the seasonality in production, left panel, and seasonality in birth weight, right panel. And as we see, birth weight is highly seasonal. Across different years, we see very similar patterns that babies born in spring and summer have higher birth weight, and babies born in December and January have lower birth weight. And it's true across all years. But when we look at the seasonality in production across different months of the year, there is no seasonality. The production is fairly constant. Why? Because once a well is drilled, the amount of production and extraction is based on mainly technology and then the capacity of that reservoir, and definitely not on month of the year, on quarter of the year, on the season of the year. So there is no concern about uh, the probable association between seasonality in birth weight and production that may underbias or overbias the estimates. Now that we've seen production is associated with negative birth outcome, we talked about main results, subsamples, heterogeneity, and some concerns over endogeneity. Here we will talk about the implications and economic significance of the results. So many studies show that health endowment at birth have short-term and long-term effects. For example, birth weight and low birth weight are associated with infant mortality. We use matched multiple birth data to investigate this link, to reevaluate this link. Matched multiple birth data is birth certificate data for multiple birth, which means twins, triplets, etc., and follows them into their first year of life and reports whether they're still alive or not. We use a twin fixed effect strategy and find that an increase of 1 gram in birth weight reduces the likelihood of infant death by 0.16 basis point. Also, being low birth weight raises the likelihood of infant death by 48 basis point. So we have these estimations here. And also we have the estimation of marginal effect of 1 million barrels of oil equivalent production on birth weight, which was minus 3.2 in the table of main results. Using that calculation on matched multiple birth data and this marginal effect, we see that 1 million barrels of oil equivalent production leads to about 1 more death per 100,000 live births at year 2000, calculated for year 2000, which is about 0.15% rise from the mean. Using the marginal effect on low birth weight and the calculation of matched multiple birth data, we see that 1 million barrels of oil equivalent production leads to about 0.12 more death per 100,000 live births. You may think that these are very small effects, but we're talking only about 1 million barrel. Remember that. Now, another implication of having a low birth weight, having a low health endowment at birth, is that of hospital discharge cost. In an interesting study, Almond, Che, and Lee, 2005, use a twin fixed effect strategy and calculate the hospital discharge cost for low birth weight children in excess of children with a normal birth weight. Now, we use their calculations and the marginal effects in the main table, and we find that 1 million barrels of oil equivalent production leads to $3.5 million additional cost in hospital discharge cost. And this is only related to year 2000, where we had about 300,000 low birth weight in the whole US. $3.5 million for 1 million barrels of oil equivalent, but 1 million. And up to now, I used 1 million barrels as the default shock. Well, for oil producing county, the average is 2 million annually, 2 million barrels of oil equivalent production. But this annual average is not uniformly distributed. Looking at the top quartile of production, the annual average is 8 million. Standard deviation is 22 million. At the top 10th percentile, the annual average is about 20 million annually. Standard deviation is about 32 million. In a specific example, Weld County in Colorado, which has a population of about 252,000 people in 2010 census, has an annual production of 242 million per year. 242. Now, we see that there are mothers at top percentiles that are at much higher risks than the feeling we get when we look at that minus 3.2 gram, that marginal effect. They are at much higher risks. Okay. Now, finally, the conclusion. In summary, in this paper, we investigated the effect of oil and gas production on pollution, and we showed that it does increase pollution. And we showed that the oil and gas extraction is associated with negative birth outcomes. As an example, 1 million barrels of oil equivalent production in the county of residence during prenatal development period, in utero period, is associated with 13 basis point increase in likelihood of a low birth weight. However, the results are heterogeneous across different types of drilling, with the largest effects coming from vertical and then directional types of drilling. We talked about some endogenous fertility issue and seasonality in birth outcome issue, and we didn't find any evidence that these endogenous fertility or the seasonality is driving the main results. And then I talked about the implication of the results for infant mortality and hospital discharge cost. So if I want to wrap up everything in one sentence, I can say that there are negative health externalities from drilling oil and gas extraction on infants' birth outcomes. That was the main conclusion of this paper. So, any questions for me?
Thanks very much. That was a great talk. I have one question while maybe others are thinking. Okay. Is when you do this county level analysis, of course, all the people in each county are distributed across the space of the county, and these wells are in very particular locations, so that some people in the county might be many miles away from the well, and others might be very close to the well, which is to say that you're estimating an average effect across all those types of all those effects being close to the well versus not close to the well. So I'm wondering if you've thought about that issue in terms of, sort of restate that, there's probably a bunch of people in the county that are far enough away from the well that the effect on them are zero, and those are being averaged into the effects that you're getting for those people who are closer and are directly affected. I'm wondering if you have thoughts on that issue in terms of the magnitudes that you're showing in the results.
So you're absolutely right. These are the average effects. There are people far away from wells and some people very close. But see, for example, we are including log of population. So it doesn't actually answer that, but we are including log of population. And we are including county fixed effect, and that county fixed effect is just controlling for that geographically fixed, like the area of the county, or log of population shows how populated is the county. So we get different results for different counties based on their population. But you're right, probably a better approach, which I'm thinking now, is that what I did for pollution, So if you look at the pollution here we are reporting pollution per county area. So a better approach probably is to go for production per county area or production per population, but I'm not sure which one is better to get a better estimate, to
One
take
thought
into account that.
this is maybe a clarification, but you probably know, well, so two related questions. Do you actually know the um, latitude and longitude of the wells and of the um, pollution monitors?
Unfortunately not. It's not included.
Neither. Do you know neither of those?
Not the latitude and longitude for production data.
I see. Okay,
At
so
least,
that's already aggregated to the county level for you?
mm, uh, in a way, yes. In some cases, they report at different regions, so at borough or county,
Mhm.
and so in very mostly maybe 99% at the county, yes, but in 1% no, at different region levels. So yeah, I had to do manually to map them to the county, but in 99% yes, it's at the county level.
And Wei has a question. Wei, would you mind unmuting yourself and asking it?
Excuse me, I didn't.
Sure, Hamid. Thanks for a great talk. I just have a question about the different associations between types of production and birth outcomes. Do you have any hypotheses why different types affect health differently?
Hmm. Why vertical is affecting, for example, larger than directional in terms
Yeah.
of the engineering type, huh? The engineering hypothesis behind that. Well, no, not exactly. And that's a good comment. Maybe we should look into this. Why vertical is affecting health outcomes more than, for example, horizontal. But no, here we just investigated the effect of type of drilling. But no, it's interesting to look into the engineering part of drilling. Why does it make it more pollution and much larger health outcomes? That's a good
Yeah, I
comment.
was thinking maybe it's because different types of production are associated with different levels of pollution production. So it would be interesting to look at
Uh-huh.
relationship
Yes,
between types of production and the pollution levels.
yes, that would be interesting. Yeah, that could add to the paper. I agree.
Mhm.
I absolutely agree.
Thanks.
I have a question, if I can jump in.
Please.
Um, so I'm curious about if I'm right, I saw maybe 40% of counties had pollution monitors. Is that right?
Yes, that's correct.
Do you know why that's the case?
That's the EPA reporting data. I mean, why that's the case for just give me a second. Let me find that slide. Pollution maps. So here, the distribution of those pollution monitors in dark colors and those counties that have no pollution monitor in lighter colors. You see
Right.
uh, why they don't report? Because they don't have pollution monitor.
So I'm just curiously, I mean, you could see there's, I mean, just remembering the map of drilling data, right? Like production data, there seems to be a pretty substantial missing
Yes,
um,
that's very, very
swath up
correct.
there. So I'm wondering if you think that that might be like intentional that they don't have monitors there, or if it's just a, you know, a product of maybe rurality or something like that.
Um, I don't know about the reason, but yeah, you're right. I totally agree with you. And if you look at most of these studies, either for pollution on birth outcome or drilling on pollution, they are highly localized. And
Hmm.
most of them are happening like in California, where you have, see here, we have, for example, production, or when you look at the pollution monitors, they're highly clustered here.
Hmm.
Or sorry, or here, sorry, here. You see, there are almost all counties have that pollution monitors in California or New Jersey.
Mhm.
See, we have, there are localized studies. They focus on a specific region because they know that we have pollution data problem for the aggregate US, for all
Right.
US counties. That's definitely create a problem for the reasons that I discussed.
Thanks.
No problem.
And Katie has a question about if you go back to the slide where you differentiate the type of drilling as it relates to the health outcomes, and that's right, the direction. So the common way that we say fracking is meant to highlight which of those rows?
Directional and horizontal are usually referred to as fracking, hydraulic fracturing, the unconventional types, and the vertical is that of the conventional type, the one that just drill vertically and the oil and gas pops up. The first two rows are mostly related to fracking boom.
And this is restating Way's question from a few minutes ago, which is to say, if you did have pollution monitors in these places, just imagine that you did. Would you have very specific ideas about the types of pollution and the amounts of pollution as you walk down these types of production? And maybe I'd add how localized they are. Is there differences between how localized the pollution would be in these different types of production?
How localized they would be different time. Yeah, so we didn't do that for production type on pollution, and it would be interesting. Yes.
But do you have any priors, I guess? I don't really have a
Mm.
visualization of any sort of what I would expect in terms of, does the pollution extend a very small amount around something that's so far underground? Are we talking about, um, yeah, that's what it's related to both ways question and partly my original question about how close to these wells would you have to be really directly affected, and then how close could you be and be really not affected at all, and would that depend on the production type very much?
Yes, that's true. That's true. And for example, we can go through subsamples like small counties where most of the production occurs, small counties or big counties where most of the production occurs, and see the different types of drilling on earth outcome and on, sorry, different types of drilling on pollution to see how differential is the effect of different types on pollution in different localized environment in small versus large counties. That would be an addition to the paper. I agree, but we haven't done it.
Hi.
Hi.
I have a question in general about the population of people and migration into areas where there is a lot of this
Yes.
drilling. I know that you thought a lot about the demographics and the changing demographics of the population living in these around these wells, but I'm wondering, did you guys take into consideration that a lot of, like, when new wells open, certain populations follow those wells? And have you, I mean, I guess other than SES, do you think that there are other correlates of some of this birth weight, of the birth weight that is associated with people who specifically come there to work on the oil fields?
So I think we tried to answer your question. This migration issue is probably the most problematic issue, in addition to the one that Jason said. But I think we try to address this question in three ways. First, so we include many controls on demographics, but that doesn't answer our question. And we report for all counties where we're comparing the outcomes of mothers in oil and gas versus non-oil and gas counties. And if we believe that these oil and gas producing counties have specific characteristics that are different than our control group, the zero production. So when we look at this when we restrict the sample to only counties with production and we get the same results. So partly that is not the problem, the certain demographic characteristics, because in both tables, uh, we see very similar results. That's one. And second, as I mentioned in the selective fertility part, the change in demographic, so the change in demographic or the fertility response or the increase in birth is not a problem unless those mothers that come or those mothers that exist that are resident of those counties respond to the boom. And this response is different across mothers with different characteristics. You see, it will create a problem. That migration and fertility decision creates a problem if some certain demographic and socioeconomic characteristics or other characteristics made them select themselves into fertility. Well, some of these characteristics, like race, ethnicity, marital status, and education, doesn't provide us with enough evidence to think that this selective fertility is a problem. So that migration issue can be partly captured by this selective fertility as well, right? Partly captured by the fact that we are looking at the intensive margin. We are restricting the sample to those counties with production. So in a way, we don't see evidence that this migration issue is creating a problem. And also in the main result table, when we don't include any of those county covariates and demographic characteristic, we still get very similar results. And we see even larger results when we include county by year fixed effect that completely controls for all these migration issues that happen over a year, right? Did
Thank you.
I? Okay. Okay.
I mean, while you're on that slide, I just had a very quick question about the interpretation of the birth count that you have bolded. Could you just tell me what the units are? Can you remind me about that?
Birth counts is the number of births in the
So is it
county in a year.
one, like that's like 3/4 of one birth extra per million barrels?
Yes. Yes.
Okay.
Yes, exactly that. It's number of birth. Yeah. Number of.
Hi, Hamid.
Hi.
This is Katie.
Yeah.
Going back to the question that I was asking about the which types of drilling kind of constitute what we think of as fracking. Do you have any instances in your data where counties kind of switch between types of drilling? And do you have any sense of whether a certain type of drilling produces more negative outcomes relative to other types of drilling from that data, or anything like that?
Counties that switch from vertical to directional, for example.
Yeah, something like that.
And that creates a problem. So, this fracking boom occurred, increased the production of counties that had already vertical production. And it happened in counties, in most cases, in counties that didn't have any production at all. Okay. So that it was, there's a substitution between these two. Well, one thing that we can think about is to restrict the sample to those counties with no production before the fracking boom, and see what are the results in that subsample. And then when we compare, we can have an idea whether this switch, this substitution can create a problem or not. But I have to think about it. Well, that's a good comment. I appreciate it. It's interesting comment, but the way to look into this, I have to think.
Yeah, no, I was just kind of curious, but yeah, super interesting.
Yeah, it's interesting that how switch between different types could affect the results.
Right, but it's sounding like you might not have a whole lot of counties that are actually switching types, right?
Yes, yes. So
Okay.
see, it's all about the production, right? As long as this reservoir has any capacity, the production continues vertically. And when the fracking technology increased, they find new reservoir and they drill and they continue production until the well has any oil and gas capacity, right? So thinking about this switch from vertical to directional, I mean, why should they? Or maybe they do. I should think about it, or at least read um, if this is the case or not. Look into the data. Yeah, that's an
Okay,
interesting
thanks.
point. No problem.
I do have one more question.
Yes, please.
So I really like that you've looked at infant birth weight here. I think it's such a good indicator of like holistic health, especially amongst infants, and touches on so many other things in later life. I'm wondering if you'd thought about looking like supplementally at other types of infant outcomes that birth weight might shape. So like infant mortality or like birth defects or anything like that.
Well, that would be an interesting idea to look into infant mortality, but it needs another data set, and I think it will be a new project, right?
Right. That's
Yeah,
probably future research, but
yeah,
it would
future
definitely add to
research.
this story.
Yeah, it definitely adds. But I should mention that, so when I presented this paper, when I presented this idea to Kai, it was about infant mortality. But
Mhm.
then when we applied for natality and fetal death first, because we wanted to see what are the effects on birth weight, and then going to infant mortality. Now that you mentioned that, I remembered that the idea was about infant mortality at the beginning, but Kai told me that let's look at the birth weight, birth outcomes first. So we looked at birth outcomes first. And of course, I looked at the fetal death, but the results was very mixed and inconclusive. So here, just looking at the birth outcomes. But yes, definitely infant mortality is another interesting outcome, and for future research, of course, yes.
Cool. Thanks.